Hello, everybody. Mr. Reeves here with you yet again as we yet again talk about scientific notation. So, we have learned what scientific notation is, how to write numbers in scientific notation, and to take them back out again. We've learned how to add and subtract and multiply and divide in scientific notation. And now we are going to do some problem solving in scientific notation. All right, so here we go. So let's talk first about a vocabulary term, and that vocabulary term is total. When you see total, you should be thinking the operation of addition. As you students know, when you are doing problem solving, many times it comes down to taking words and translating it into operations. So I want to let you know when you see that word total, you should be thinking, I need to do some addition. All right, so according to this table, in 2011, the United States had approximately 3.1 times 10 to the 8 people, and Canada had approximately 3.38 times 10 to the 7th people. So let me ask you, what is the total population of North America, which is made up of the United States and Canada? What was the total population of North America in 2011? So I need to add these two numbers together. But as you remember, you cannot add 3.1 times 10 to the 8th to 3.38 times 10 to the 7th because the powers of 10 are different. So I'm going to take Canada, 3.38 times 10 to the 7th, and I want to rewrite it as a power of 10 to the 8th, right? So I want it to be 10 to the 8th power. So what did I just do? I just made this 10 times bigger. So I have to make this one 10 times smaller. So I actually did this in one of my previous videos. I showed you how it became 0.338 times 10 to the 8th, right? So if you make the power of 10 10 times bigger, you must make the coefficient 10 times smaller. So now I know that the United States was 3.1 times 10 to the 8th, and I'm going to add that to 0.338 times 10 to the 8th. And you might think it would be 10 to the 16th, but we know that's not the case, right? This power of 10 is like our common denominator in fractions, and we simply need to add these together. And we get 8, and we get 3, and we get 4, and we get 3.438. So if I were to ask you what was the total population of the United States and Canada combined, what was the total population in 2011? 3.438 times 10 to the 8th power. All right? Okay, so that is the first problem. Now let's go ahead and look at this. Using the population table in the example, how many more people live in Mexico than Canada? So now let's talk about this term, how many more. All right, if I have 10 cookies and you have 3 cookies, and I say, how many more cookies do I have than you? What operation would you do? Would you add, subtract, multiply, or divide? Of course you would subtract, right? You would do 10 cookies minus 3 cookies, and you would get 7 cookies. So again, when you see the word total, you should think addition. When you see how many more, you should subtract. So how many more people live in Mexico than in Canada? All right, so let's go back over here. Mexico, right? Mexico was 1.1 times 10 to the 8th, and we want to subtract Canada, which was 3.38 times 10 to the 7th. Now again, we cannot do that subtraction problem as it's written because 3.38 times 10 to the 7th does not have the same power as 1.1 times 10 to the 8th. The good news is we already changed this one, didn't we? All right, we know that 3.38 times 10 to the 7th is 0.338 times 10 to the 8th, right? Mexico is 1.1. I'm going to put those zeros times 10 to the 8th. And when we subtract, of course, it's not going to be 10 to the 8th minus 10 to the 8th gives us 0. All right, when you add or subtract, the power of 10 stays the same. And now we're going to have to do some of this fun borrowing stuff, right? So I'm going to have to borrow here, and this is going to become, well, actually I have to borrow here, don't I? This becomes a 0, and this becomes a 10, but I borrowed 1, so it's a 9. So now I have 10 minus 8 is 2. All right, so 10 minus 8 is 2. 9 minus 3 is 6. And then I have 10 minus 3 is 7, right? So I get 0.762 times 10 to the 8th. By the way, as I mentioned in the previous video or videos, it's okay to use the calculator for problems like this. So if I wanted to check my math because I'm not really trusting myself right now, 1.1 minus 0.338, I could see that I actually got it right, 0.762. Now, that answer is not in scientific notation, and I believe the question actually asked us to write our answer in scientific notation. So we had 0.762 times 10 to the 8th power, right? So that would be incorrect because this number is not between 1 and 9, right? So I'm going to change this to 7.62, right? But I just made this one 10 times bigger, so I have to do what with this one? I have to make this one 10 times smaller, right? So 0.762 times 10 to the 8th becomes 7.62 times 10 to the 7th. Again, this number here has to be greater than or equal to 1 and less than 9. That's why I changed it. So there were that many more people in Mexico than in Canada. Did you guys know that there were more people in Mexico than Canada? I bet you didn't. Okay, what are some other types of problems we might be asked to do? All right, let's see here. Let's talk about this term on average, okay? On average. How do you find the average? How do you find the average of something? Well, to find the average, you take the total, right? And you divide by the number of data. All right, so if you had 5 tests and you wanted to know your average, you would add up the total scores and you would divide by 5. Okay, so average says average is going to be, when you see average, you should think division. All right, that's the operation you should think when you see average. All right, so here we go. Light travels at the speed of 1.17 times 10 to the 7th miles per minute. So they gave us a speed. Pluto's average distance, all right, distance from the sun. So they gave us distance. We also need to know this thing called distance is equal to rate times time. All right, so they're asking us how long. So how long is time? They're asking us a time when they give us a rate and they give us a distance. So distance is equal to rate times time, or time is equal to distance divided by rate, okay? Time is equal to distance divided by rate. So we need to do distance divided by rate to give us our time. So the distance was, now I'm going to change this to scientific notation, 3, 6, 9. So we have 3.67 times 10 to the 9th. That is our distance, right? That's the distance from Pluto to the sun. The speed of light is 1.17 times 10 to the 7th. All right, and remember the great thing about multiplication and division is we don't have to worry about common denominators, so to speak, or common powers. We can just do this, right? So what is the operation we use when in a division problem? We subtract, right? And we get 10 to the second power. And then I'm going to go ahead right now, and I said it's okay to use a calculator, especially for problems like this. I'm going to do 3.67, and I'm going to divide that by 1.17, and I get 3.13 da 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 da. All right, so I'm going to go, they went 2 places here, so I'm going to go ahead and go 2 places. So I'm going to go 3.14, okay? 3.14 times 10 to the second. Now what is our units? Let's see, we had miles per minute, and this is time, so it's going to take 3.14 times 10 to the second minutes, which of course is, if they didn't ask it for in scientific notation, 314 minutes. All right, and we know there's 60 minutes in an hour, so it's about 5 hours, right? 5 hours and 14 minutes for light to travel from the sun to Pluto. All right, okay. So again, when you see that word average, you should be thinking division, although to be honest, in this problem, it meant something a little bit different. But distance is equal to rate times time. This is also something you need to know for problem solving. All right, so let's go ahead and take a look at a different problem here. Okay, these are all just computation problems. Let's get to some word problems. Here we go. All right, now we're talking. Look at all of these wonderful word problems. All right, an adult blue male can eat 4 times 10 to the 7th krill in a day. At that rate, how many krill can the adult whale eat in 3.65 times 10 to the 2 days? All right, now this problem looks really scary because of this scientific notation. All right, I'll never forget when I was a young child and my mom was trying to help me learn some math. One of the skills she taught me was work with smaller numbers. And then whatever you would do to solve the problem with smaller numbers is the same thing you will do with bigger numbers. So let's just change this to something that makes a little more sense with numbers we can wrap our head around. So let's just say an adult blue whale can eat 10 krill in a day. Okay? At that rate, how many krill can he eat in, let's say, 5 days? So if these numbers were much more simple, if he can eat 10 krill in a day, how many can he eat in 5 days? I think most of you would probably quickly say 50. And how did you get that? You did 10 per day times 5 days equals 50 days. So what operation are we looking for this problem? We're looking for multiplication, okay? So multiplication is the operation we're going to use when they give you a rate times a time. Remember in the previous problem we said distance is equal to rate times time. All right, this is, in this case, this would be the distance is actually how many total krill he can eat. So what do we want to do? We want to do 4 times 10 to the 7th times 3.65 times 10 to the second. All right, we want to do that multiplication problem. So again, the first thing I'm going to do is these right here. 10 to the 7th times 10 to the second. You know we want to add those, right? And we get 10 to the 9th. And then I'm going to go ahead and get out my handy dandy calculator. All right, that screen's getting kind of full, so I'm going to clear it out. And I'm going to do 4 times 3.65. And when I do 4 times 3.65, what do I get? I get 14.6. All right. Now, once again, that answer is not in scientific notation. So 14.6 is too big, right? I need to change that to 1.46. What did I just do? I made this number 10 times smaller. So this one must get 10 times bigger, and it becomes 1.46 times 10 to the 10. That is how many krill an adult blue whale can eat in a day. That's a lot of krill. All right. Okay, what about this one right here? A newborn baby has this many cells, an adult has that many cells. About how many times as many? Okay, so again, let's go back to easy numbers. If I am 10 years old and you are 2 years old, and I say, about how many times as old am I as you? How many times means I need to do what? It means I need to divide, right? We need to divide the bigger number by the smaller number. Okay, so we have the adult. The adult is 4.94 times 10 to the 13th power. And I'm going to divide that by the baby. And again, I'm going to change this to scientific notation. 3, 6, 9, 10. 2.6 times 10 to the 10. And again, it is so nice. Multiplication and division is much easier than addition and subtraction, because all I'm going to do here, what operation do I do in division? I subtract, all right? And so that gives me 10 to the third. And then I'm letting you use a calculator. That would be the worst part of these problems. 4.94 divided by 2.6. And when I do that, I get 1.9. Yay, it's even in scientific notation. All right. Now, but then it says write your answer in standard notation, which means I need to move the decimal 3 places, right? So I get 1, 9, and then 2, 0. About 1900 times as many. Okay? All right. So if we had a total meant for us to add, right? If we go back, let's just go back to what we had at the beginning. We talked about how the word total told us that we needed to add. We talked about the word how many more tells us we need to subtract. When we see the word average, we know we need to divide. All right, so when you see average, we need to know this relationship that distance is equal to rate times time. All right, when we see how many times as many, we're going to divide. All right, let's take a look at these last problems and see if there's any new vocabulary. All right, so here's total. That means we're going to add. Here's total. That means we're going to add. How many times greater? That means we're going to what? Divide. All right, here's average. Remember, average is going to be the total. So for this one right here, the Australia, the area of Australia is that. So we have the area, right, divided by the number of people. What is the average number of people per square mile? Actually, they want it the other way, don't they? They want the number of people per square mile. So it's the number of people over the area in this case, okay? That's what they want. They want the average. So, excuse me. Let me do that again. So this one's going to be the number of people over the total area. So the number of people in Australia is 2.15 times 10 to the 7th power, right? And the total area of Australia is 2.95 times 10 to the 6th power. Okay, so then we would do that problem. Remember, with scientific notation, you can just subtract the exponents and divide. And remember to make sure you write your answer in scientific notation. Although in this case, the approximate average number of people, you're going to find out it's actually a pretty small number. All right. And how many more? We already said how many more is subtraction. There's one more thing here, recovery ratio. Let's talk real quick about recovery ratio. A ratio, again, tells us we're going to divide. So ratio is going to equal division. And a recovery ratio is going to be recovered over generated. Okay, so recovery ratio is going to be recovered. Sorry, let me try this again. Equals recovered over generated. So when it says which one has the greatest recovery ratio, you're going to have to divide all of them, recovered over generated, recovered over generated, recovered over generated, and see which one is the biggest number. What do you think? Paper, glass, or plastic? Which one do we recycle the best? All right. So I know I didn't do every problem with you, but hopefully that helps you get through that lesson. As always, you can always email me with any more questions that you have. All right, I know this was a super duper big long lesson. I'm sorry. Had to get it done before the end of the quarter. All right, have a great day, everybody. Till next time.